For this lesson, we're going to continue our look at rational expressions. In previous lessons, we looked at multiplication and division of rational expressions, and we're going to be looking at adding and subtracting here, which is actually a little bit more, there's one extra step that we have to worry about, which is why I did them in the order that I did. Before we go on to the actual rational expressions using polynomials, just a very quick review of reminding you about this very important idea of lowest common denominator when we're combining fractions. So if this is something that you are accomplished with, you might want to jump ahead. In this case, I've got 1/2 plus 1/5. The lowest common denominator, if your denominators are prime numbers, the easiest way to come up with the lowest common denominator is simply to multiply the two prime numbers together. So in that case, we end up with 10. The process that you want to go through in order to get these into a common denominator is your target is now 10. So what do I have to do to the number 2 to change it into 10? I have to multiply it by 5. But I'm not allowed to just multiply the denominator by 5. I have to multiply both numerator and denominator by 5. To change the 5 into 10, I'm going to multiply it by 2, but I have to multiply both the numerator and denominator by 2. And the reason for that is because 5 over 5 is actually equal to 1. And 2 over 2 is actually equal to 1. So what I've done is I've multiplied 1/2 multiplied by 1, which is of course still 1/2. 1/5 times 1 is still 1/5. All I'm doing here in forming these common denominators is I am changing the look of the fraction, but not the actual value. So for example, 5 over 10 is still equal to 1/2, and 2 over 10 is still equal to 1/5, and I combine those now. I perform my operation of addition, and I end up with 7 over 10. Now this next one, not a lot more difficult. Like I say, this should be a very familiar review for most people, but in this case the numbers are not prime. So what I want to do is I want to make sure the lowest common denominator has all of the factors of the respective denominators represented. So the number 2, well, that's actually just the number 2. 2 is a prime number. The number 14 is equal to 2 times 7. So our lowest common denominator, the way we form this, is we take a look and we go to either of these. I'm going to start here with 2, and that means that this and this are now represented. And I go to 7. There's a 7 here. This whole value is done already, so 2 times 7 is equal to 14. So I ask myself, what do I need to do in order to get a denominator of 14 here? Well, I have to take this one and multiply both the numerator and denominator by 7. And so this ends up being 7 over 14, which of course is still the same as 1/2, plus 3 over 14. That gives me a total of 10 over 14. And I always need to consider whether or not I can actually reduce my answer. And in this case, the number 2 goes into 10 5 times, and the number 2 goes into 14 7 times. And so I end up with my final answer, which is 5 over 7. In this case, neither of my denominators are prime numbers. So I'm going to go through that same process. I'm sure many of you can just look at this and know what the answer is, but the number 6 is the same as 2 times 3. The number 8 is the same as 2 times 2 times 2. And so now my lowest common denominator, I start off with the 2. That takes care of those ones. I then have a 3, which takes care of that, a 2, and a 2. And so my lowest common denominator here is actually equal to 24. So rewriting 5 over 6, what do I have to do to 5 over 6 to turn it into something over 24? I need to multiply the denominator by 4, which means I have to multiply the numerator by 4, minus 3 over 8, and I have to multiply the denominator by 3 and the numerator by 3, 5 times 4 gives me 20, and this is now over 24, minus 9 over 24. 20 minus 9 is equal to 11 over 24. There are no common factors between 11 and 24, so I'm done. This last one, you notice that I don't have any numbers. I just have variables. But these variables are still the idea of factors. The variable b, if you want to think of it, you can actually think of it this way. B is just equal to b. I can't break that down any further. D, of course, is just equal to d. Now you might wonder, well, why are you writing it this way? If I had something like x squared in the denominator, you might want to think of that as x times x. So that's why I'm just illustrating to you that we're still going to write these in terms of their factors. So in this case, my lowest common denominator becomes BD. It's the B value and the D value multiplied together. So that means this is equal to A over B. And in order to get a denominator of BD, I need to multiply by D, I need to multiply by D. Plus C over D. And in order to get a denominator of BD, I have to multiply by B, I have to multiply by B. And I end up overall with AD plus BC divided by the denominator BD. And I did rearrange the order of a couple of these things because convention in math is we normally, but not always, but we typically try to write our variables in alphabetical order just for consistency as well. It makes it easier to identify common terms. So now that we've gone through that refresher on common denominators and combining fractions, let's go ahead and try to do this with polynomial rational expressions. The focus to start is on the lowest common denominator, which of course means the denominators themselves. In this case, the factor x plus 1 and the factor x plus 2, they're not the same, and so my lowest common denominator is just going to be the product of x plus 1 times x plus 2. This is like the prime numbers that we had before. So this is equal to, I'm going to rewrite, you don't have to write all of these steps. I'm writing every step just to try to avoid confusion. So what I'm going to do is ask myself, how do I make this denominator out of this original denominator? And the answer is I need to multiply x plus 1 multiplied by x plus 2. But to do that, that means I have to multiply both the numerator and denominator by that factor. Plus 3x over x plus 2. And once again, how do I get an overall denominator of x plus 1 times x plus 2? The x plus 2 is already here, but what's missing is the factor x plus 1, the factor x plus 1. Now, in the numerator, I'm going to expand and simplify. There's no good reason to expand and simplify in the denominator, so I would just leave it in terms of x plus 1 times x plus 2. X times x plus 2 gives me x squared plus 2x plus the denominator of the other one is going to be 3x squared plus 3. Notice that I've put brackets around each of the individual numerators that I expanded and simplified. When it's addition like this, this is really overkill. You don't need to do this, but with subtraction, this is actually quite a useful strategy. So for the examples that I'm going to be doing in this lesson, I'm just going to do that overall. It does keep things a little bit better organized. It saves you making silly errors. X squared plus 3x squared is 4x squared. Positive 2x, well, there's just a positive 2x actually. And sorry, I should have written 3x there. Small mistake. So this actually is not plus 2x. This is plus 5x. All divided by x plus 1, x plus 2. And the reason why I don't recommend that you expand and simplify the denominator is because we actually, once we've simplified this numerator, we need to refactor if possible to see whether or not there's any further simplification by dividing out factors. Looking at this numerator, I do see a common factor of x, which leaves the factor 4x plus 5 in the numerator, and then the denominator is x plus 1, x plus 2, and of course none of the factors in the numerator will divide out with any of the factors in the denominator, and so all we have left to do is to state our restrictions, which is that x is not allowed to be equal to -1, x is not allowed to be equal to -2. In general, you can see we started with factoring the denominator if necessary. Actually, in our original question there, we didn't have to do this yet. Identifying restrictions, you'll notice that I identified my restrictions at the end. There is some movement you can have in these, the order of these steps, but you always need to be thinking about restrictions. Finding the lowest common denominator, express the rational expression as a single expression with the same lowest common denominator, perform your algebraic operation, addition or subtraction, and then if possible, we're going to factor the numerator and simplify with the factors, common factors between numerator and denominator. This won't happen very often, but when it does happen, it's very important to catch it. Okay, let's ramp up the difficulty only a little, but it is a significant next step. The lowest common denominator in this case. So let's first of all, we have the first term has an x minus 2. The next term has an x minus 2 all squared, which is the same thing as x minus 2 times x minus 2. So in creating our common denominator, we're going to look at these factors. So I see x minus 2 here, but this x minus 2 is taken care of in both places. So a single x minus 2 represents both of those x minus 2's. But there is also a second x minus 2, so we actually have to write it like this, which basically takes us back to the second denominator, x minus 2 all squared. So we have to turn both of these denominators into x minus 2 all squared. Well, with the first term, which is x plus 2 over x minus 2, to make that change, I need to multiply by another x minus 2. That makes it into x minus 2 all squared. And I, of course, have to multiply the numerator by x minus 2. Minus x over x minus 2 all squared. Well, x minus 2 all squared is the lowest common denominator. This one is already done. Is equal to. So now everything is over x minus 2 all squared. I expand this first numerator. That is actually a difference of squares. So that's x squared minus 4. And minus, and the second numerator is simply x. So I really don't need this bracket here at all because it's a single term, but just for consistency I'm going to go ahead and include it. So what do we have left over in our numerator? We have an x squared minus an x minus 4, all divided by x squared. It's x minus 2 all squared. So the next thing you want to do is you still do need to check whether or not you can factor this. And so we're looking for a sum of -1, a product of -4. Are there any integers that multiply to -4 and add to -1? And they are not. There are no integers. There's no rational factors for this. So this is actually our final answer. And as far as restrictions, as I said, we always have to keep restrictions in mind. With these addition and subtraction questions, we're not going to have as much likelihood of factors disappearing on us, but it can happen. So we always need to, if we have divided out any pairs of factors, go back to the original. Since we haven't lost anything in what we've done here so far, we have the single restriction, which is that x is not allowed to be equal to 2. Okay, in this case, first thing we're going to do is factor the denominators. So that's 2 over common factor of x, x plus 1, plus x over, and this is a difference of squares. This is x minus 1, x plus 1. So now my lowest common denominator is going to be all of these factors represented. So an x has to be represented, and it's not represented anywhere else. So we've got that x. We've got an x plus 1, and it is represented to the power of 1 in both of the denominators. So that's all I need. And then we have an x minus 1, and it's only represented here. But now this common denominator represents all possible factors in the denominators. So what do I need to do to this first term to turn it into this denominator? I'm going to need to multiply by x minus 1, both numerator and denominator. For this second term, I'm going to have to multiply by, looks like the thing that's missing is an x. So multiply both numerator and denominator by x. I'm going to leave the denominator as x times x minus 1 times x plus 1. The first numerator becomes 2x minus 2, plus the second numerator is simply x squared, so you can put the brackets in or not put the brackets in here. It's a single term. Normally we would rewrite this as x squared plus 2x minus 2 over x times x minus 1 times x plus 1. We have to ask ourselves about factoring sum, product, and integers. The product is negative 2. The sum is positive 2. Are there any integers that give us that sum and product? And the answer is no. So we are now done. We have not lost any of our factors, and so our restrictions, which I can read here, are the same restrictions I would get from reading originally, and I end up with x is not allowed to be equal to 0, x is not allowed to be equal to 1, x is not allowed to be equal to negative 1. There's a more concise way that we will sometimes write this. Sometimes we will just write this as a list. X is not allowed to be equal to 0, comma, 1, comma, negative 1. Or an even more concise way you might write this is x is not allowed to be equal to 0, comma, plus or minus 1. All three of these contain that same information with regard to the restrictions. Okay, moving on to something even more complicated looking. Once again, I'm going to start with my factoring step. Don't forget to factor numbers as well. In this case, I have a common factor of 2 in the numerator, which gives me x minus 3 as the other factor. 3 in the denominator, which gives me x plus 2 as my factor. X minus 3 is already as factored as it's going to be. And x squared plus 5x plus 6, what are two numbers that multiply to 6, add to 5, and those two numbers are 2 and 3. So this denominator is x plus 2, x plus 3. Everything is now factored. You do want to take a look and see whether or not you can simplify things right away, maybe divide out a factor. And as soon as you start thinking about doing that, you really need to be careful about keeping track of your restrictions. This is why keeping track of our restrictions right now is a good idea. We're not going to lose anything here, but I'm going to show you in the other order. So now I'm going to set my restrictions, which is this first one tells me that x is not allowed to be -2. Then I end up with the same thing, x is not allowed to be -2, and x is not allowed to be -3. So you could do that earlier or later, but the responsibility is on you in order to make sure that you don't lose any information. Now, common denominator, the lowest common denominator here, we have to make sure that everything is represented. So that includes this number 3 and the factor x plus 2. Now the factor x plus 2 is actually represented in both of the denominators, and the factor x plus 3, which is only represented in this right-hand denominator. So the first fraction, 2 times x minus 3 over 3 times x plus 2. How do I get this common denominator? I need the x plus 3. So I multiply by x plus 3, but I have to do that both numerator and denominator. This is addition, x minus 3 over x plus 2, x plus 3. And what's missing now is just the number 3. So now I have created a common denominator. So that is going to be equal to, I might want to do this in a couple of steps. First of all, my overall denominator is 3 times x plus 2 times x plus 3. And my numerator is going to be 2, and then I'm going to expand out this set of brackets. But this is x minus 3 times x plus 3, which is a difference of squares. That's x squared minus 9. Plus, and I can go ahead and expand in 3 times x minus 3 is 3x minus 9 is equal to 2x squared plus 3x, and 2 times -9 is -18, minus 9 is -27, all divided by 3 times x plus 2 times x plus 3. We've ended up with a complex trinomial here, but we still need to consider factors, and using something like the general quadratic formula is not advisable here, because in order to be able to divide out if there's a common factor, we do need it into a factored form, a rational factored form. So sum, product, and integers. Now we need a sum of 3, and we need a product of 2 times -27, which is -54. So we're going to have to multiply together a positive and a negative. So let's just look at the number 54. It's 2 times 27 gets us there. Well, it's not that. What about 18? 3 times 18. So let's look at that. We've got 1 times 54, 2 times 27, 3 times 18. What else can we get from here? We could have 4 will not go in there. We have 6 going in there as well. What do I take the 2 out? 6 times 9, of course, 54. 6 times 9 has our difference of 3. And so that looks like what we want here. And because we want the sum to be positive 3, our numbers are going to be 9 and -6. So those are going to be the two factors. So that is equal to, and you might want to, because it gets quite tedious to write out these fractions over fractions over fractions, there is certainly nothing wrong with doing this factoring as your rough work. So 2x squared, and instead of 3x, I'm going to write that as plus 9x minus 6x minus 27. And that's equal to, common factor here is x, and then I get 2x plus 9 minus 3, and then 2x plus 9. And so this ends up being 2x plus 9, x minus 3. And so that becomes my new numerator. So it's going to be 2x plus 9, x minus 3, all divided by 3 times x plus 2 times x plus 3. So there are no common factors between numerator and denominator, and we state our restrictions or restate our restrictions. X is not equal to -2 or -3. So quite a bit more involved just with the different algebraic skills that we have to make use of. No single piece here is particularly elaborate, but you do have to know enough to be able to put them all together. Okay, and that's it. So those examples cover a pretty good representation of the different things you'll see when you're dealing with questions like this.